Good morning, everyone. My name is Paul Elstrom. I'm the CEO and founder of Tropos, and we thank you for our selection into the final round. At Tropos, our mission is to leverage technology to improve crop outcomes in the controlled environment agriculture, or CEA, industry. Here are a few facts to consider. This heat map highlights severe water issues across the United States. Dark red is obviously not good. It reflects that we're quickly running out of water out west where most of our produce is grown. Many experts agree that we'll need a 50% increase in food production to feed the planet by 2050. This will require a farmable landmass twice the size of India if conventional farming methods are pursued. That is simply not going to happen. Current farming methods and resource limitations can't scale to meet the demand. You couple that with a consumer desire for more local produce, fewer food miles, and it's no wonder billions have been invested in ag tech by people like Jeff Bezos, Steve Case, and others looking for a new food model. Some of you may recognize this picture up here. This is the Sony Walkman, one of the first portable music players. It was revolutionary when it was introduced in 1979, but it can't hold a candle to today's smartphones. With their integrated functionality, there's just no match. The situation is similar in the CEA industry. Greenhouses have been around for decades, but many are still managed by passive control systems that are slow to react and can't manage indoor climate in real time. As a result, issues like mold and mildew develop for growers who operate them. The answer is Tropos and our patented mixing box solution, which manages indoor climate and continuously controls temperature, humidity, CO2, and transpired water from the plants in real time. The type of high-density farming we are moving to requires a holistic, engineered, and integrated approach that is currently not available. This is a rendering of our mixing box design. In any greenhouse or grow room, plants transpire and give off water vapor as they grow. As a result, the returning air becomes saturated and the relative humidity level in the space will increase. Our closed-loop HVAC system carries that saturated air back to our air handling system where it passes a sensor that will measure the CO2 concentration. Our software then directs, based on the grower-specified predetermined set points, how much CO2 to dose via that mixing tee you see there to start conditioning the air before being returned to the grow room. The CO2 dosed air is then filtered to MERV 13 standards and conditioned by the cooling and heating coils to the desired relative humidity and temperature. And these coils in series are extremely efficient, and they eliminate the need for a separate dehumidifier that is so often seen in cannabis cultivation facilities. Benefits include better crop quality, better yields, fewer crop losses, and enhanced plant growth due to the optimal CO2 uptake. We also have seen greater sustainability, near zero net water use, and more resource efficient. This is more resource efficient when the Tropos system is integrated with an on-site microgrid that can power a facility. This is a photo of an actual mixing tee that we have at our, that is attached to our indoor cannabis facility, hemp cannabis facility in Buffalo. This is the unit where our patents are centered around, and this is an item that we will manufacture in the Grow New York region. And then here is a large-scale facility that we operate in Buffalo, New York, and it's a functioning mixing box that shows the air handlers on the north side of the greenhouse of our semi-closed 3/4 acre lettuce greenhouse, and that is managing all of the air inside of that greenhouse, and we have seen outstanding results. We used to get 10 crop cycles of lettuce there, and in the last year we got 11 and a half crop cycles, so a 15% increase. And then at Tropos, we have 3 process patents that have been issued in the United States and Canada around HVAC and CO2 supplementation. We also have copyrighted software that runs the mixing box. We have a 4th claim that is patent pending around what we feel is a breakthrough in CEA, the ability to measure CO2 uptake by the plants in real time. This will greatly benefit growers by allowing them, using our system, to track actual real-time growth rate and steer the crop to success. We are focusing on 2 major CEA segments, CEA for food and CEA for cannabis. In the vegetable segment, the compound annual growth rate has been nearly 25% for the last 15 years. Growing even faster is the cannabis market, which is actually exploding. This map, where the dark green shading indicates states where adult and medical use is legal, light green indicates where medical is legal, and yellow permits CBD hemp products. Our experts think much of this map will be dark green before the end of the decade. And cannabis is a valuable crop, and it's also a sensitive crop. And air management is critical to plant health. And experts estimate that 1 to 3 million square feet of new indoor space will be needed to meet the demand in New York State alone, and spread out over at least 150 facilities. For reference, the state of California currently has over 2,800 licensed cultivators. With nearly 3/4 of all cannabis produced indoors, we expect the eastern United States to provide a large, growing, and healthy market for our Tropos system. We plan to go to market in 2 main ways: directly with our large base of contacts we already have, and indirectly with OEMs, channel partners who already sell into the greenhouse space, as well as HVAC firms, greenhouse consultants, and the like. We also plan to engage in conventional marketing tactics using digital and social platforms, as well as science-based white papers. Detailed data exists on every greenhouse operator in the country, so we'll have a great marketing database as we formally launch. And I mentioned white papers before. This is an example of a collaboration that we did with a 2020 Grow New York winner, Candidus, where we looked at the efficiency and the improvement of utilizing their system with a grant funded by NYSERDA. We have already talked to a number of potential customers, including a division of publicly traded Gibraltar Industries in Buffalo, New York. Their subsidiary, Rough Brothers Incorporated, builds greenhouses across the United States. And we actually have a design consulting contract with Game Plan Tribal Ventures. Game Plan is out of Phoenix, Arizona, and they do meaningful non-casino economic development projects on tribal lands. And we are planning 4 greenhouses on the Navajo Nation land in Arizona and New Mexico. And we have also presented to Cornell University's greenhouse manager, who maintains dozens of greenhouses in and around Ithaca. His initial reaction was very positive, and we have scheduled a follow-up visit at our demonstration site in Buffalo. The competition includes legacy sellers into the market, such as Priva, AutoGrow, and others. However, their very capable operating system are focused on around monitoring and passive control of greenhouse climate and static data points, versus an integrated system that can drive autonomous growing decisions, making results for growers with less effort. Tropos can deliver that. Our team has worked together for many years building the first demonstration site at a large greenhouse near Buffalo that our sister company, We Feel Gardens, operates. The group possesses deep domain knowledge in plant science, heat and CO2 recovery, HVAC, systems integration, microgrid technology, food and pharmaceutical manufacturing. It also possesses significant functional experience across strategic planning, finance, marketing, sales, and project management. It's not advancing.
No go? Well, that's awkward.
Okay. We have a multifaceted business model with revenue from 3 areas. Upfront design fees to develop a customized system, equipment fabrication, markup on the mixing box, hardware which is added to an air handler unit. Thirdly, we have annual licensing fees for our software which operates the system using our proprietary algorithms. We envision a gold, silver, and bronze SaaS model which escalates the pricing as additional functionality is provided to the grower.
Great. This looks like a good place to start to hold up a little.
Here is a summary slide of our direct economic benefits. We are planning 26 installs, 21 SaaS licenses by the year of end of year 3, which would drive $5 million in sales with a 60% operating margin. We'll create 11 new jobs at our average salary of $70,000, plus 8 or so jobs with our manufacturing partners. At any award level, we'll open a technical office near Ithaca and set up a demonstration unit at Cornell. We're in the process of interviewing a number of fabrication partners, including Mercury, LTC, Cameron Manufacturing. The $1 million prize will allow us to scale more quickly, hire more staff, and work on software and sales.
So Paul, let's start taking some questions from the judges. Sorry, my friend.
Okay.
Get a little bit of space. We'll give you a little extra time because of the glitch there on the clicker. So all right, let's lead off with Andy Grievin.
Couldn't advance the slide.
I know.
Hey, can you hear me?
Yep.
I'd like to bring Steve Leas.
Bring on Steve Leas.
Okay. Hey guys, great presentation, exciting stuff. Would love to hear, how you're going to incentivize, folks to use your system. What's the price point, and is it competitive to? You mentioned a couple of the others in the market. How competitive is that pricing?
Yeah, well, from the point of view of high-value crops, like cannabis, for example, this is a value proposition that we can offer them. That there's currently a lot of segmented solutions. Like I mentioned, they have separate dehumidification units that reject heat into the space, which is inherently not sustainable. It's asking your HVAC to do more work. So we have this integrated system can produce better results, and then our discovery around CO2 supplementation, around tracking the uptake of that, is a real game changer, we think, because it is a true indication of plant growth. The only place a plant gets carbon from is atmospheric CO2, and as the building block of all the sugars, carbohydrates in the plant. So knowing what that is in real time is a tool for growers that they would love. And then as far as our price point, we think we're competitive with what the national average around per square foot for cannabis facilities, around $75 per square foot for HVAC.
Yeah, maybe just to supplement on that, Paul. So our costs are $20 to $30 a square foot on a hard cost, and then we take a markup on that install cost and so we'll sell it for $50 to $100 a square foot. So the higher value crops like cannabis or soft berries and leafy greens are incentivized to improve their yields and outcomes. So we think there's an intuitive reason for them to really look hard at the solution.
Great.
And then you've got just to supplement the market, we got a retrofit market. So there's about 158 million square feet of greenhouse to sell into. We've got probably another 5 million coming online based on projections, based on leafy green and new investment. And then the cannabis, nobody's counting it really yet in the way they should. We think it'll explode and very high value crop, particularly in the medical segment.
Let's jump to Mary for another question.
Sure, thanks. So as an engineer myself, I love anything to where you actually can, if you can measure something, you can control it. So that's really cool. But I'm thinking about the scalability of this, because it strikes me that, every new project you have to go in and do the engineering work for it. So, so basically an engineering services company that sells some hardware along. Can you just walk me through how you grow that sales model over time to where it, you know, can go faster than just become kind of one person is X, two people is, you know, 2X?
Yeah, so we, in our analysis of particularly the cannabis market, there is a typical size of a flower room. It's between 500 feet and 1,000 feet, 1,000 square feet. So we've in our research we've done at our facility there, we have a demo site, so we can size an equipment that could handle 500 to 1,000 feet. So that would be a model that could be repeatable amongst hundreds of flower rooms that already exist in the market. And then we could retrofit a lot of people's using our patented technology. We could take an air handler and add that mixing tea that would then give the grower the ability to track CO2 uptake in real time. So there is both this new market, also this retrofit market that we would be going after.
And the indirect market would be channel partners that you know, get a piece of the piece, and with distribution, with customers, you know, we want to be an ag tech company that's really, SaaS is really the long goal for us, to sell information that help them improve outcomes. So over time, we don't want to necessarily build a sales force solely, you know, it'll be initially.
Great. Great. Let's jump to John Catalbrano for a question.
Yeah, a very, very interesting technology. When you take on a project or think about a project like the tribal lands in I believe it was Arizona, so do you go into that with the thinking that you're just going to bring in the HVAC system, or you plan on putting up the greenhouse too, or how's your approach to those kinds of
Yeah, it's really
projects?
interesting that through my relationship with Cornell Control Environment Agriculture, I'm working with the University of Arizona on a desert model of this. And what they're really interested in is kind of desert greenhouses are usually cooled using wet walls, where they just use a tremendous amount of water and just blow it. Whereas we can capture, the water is the real issue out there. And by segmenting into 1 acre sections, we can capture all the water and reuse it. So that is the real attraction to desert greenhouse. So what we're doing is trials at the University of Arizona Controlled Environment Agriculture School. And then we're actually setting up a scholarship for the Navajo Nation to send one of their people to study at Controlled Environment Agriculture there. So it's a little different model over there. It's more around the water out there, but really exciting.
John Eng?
Hi. I visited your farm a couple of years ago, and I was impressed with what you were doing then. But you know, you mentioned the high-value crops, berries and leafy greens, and then cannabis in the same sentence. That's a very, very broad range in value. Does your product, is it feasible for those, the cost of it? Is it feasible for the leafy greens and berries?
Yeah, I mean, it is very crop specific. You have to have the crop, you know, the price you can get per gram of saleable weight has to, that's the kind of calculation we do as greenhouse growers, is the grams of saleable weight per kilowatt hour or BTU, your energy inputs. And that's what we really focus on. And then I didn't get a chance to talk about it, but we do have a lot of knowledge around microgrid technology. And that's the other thing about cannabis in New York, is there's simply not enough electricity to power all of these indoor farms. So we have to look to alternative things, and on-site energy production is one of them. And using cogeneration just works so well with our system, in that we are able to recover that heat and then obviously use it in the air handler and then drive chilling too as well with it. So really interesting permutations that we can do to scale this up.
Excellent. So Laura, do you have another question?
I think this is really interesting, and I'm just wondering, with the automation, do you reduce labor use and therefore cost in the greenhouse, or does this not supplement the labor that's needed?
Yeah, no, I mean, it would help the grower. I don't think it would, you know, substitute for any jobs like that, but it would give, growers thrive on information. And the more information they have, the better decisions they can make. And that's what we think our software does, is it just gives them a unique CO2 uptake in real time that hasn't been available to this date, in that we can measure the amount of CO2 going in and the amount of CO2 coming out, and the delta between that is what the plants are consuming. And having that in real time enables this machine learning and AI to really improve grower decisions and possibly eliminate a grower's decision. They can just follow a computer that is monitoring this all the time.
That's great. Any final questions? Annie.
One of the things I wanted to get a better sense of, I know you mentioned a couple of the projects you're working on. Are you working with any other partners that you feel can help advance this that you're willing to share?
Yeah, we work with some of the legacy control companies. Like our farm is managed by Priva, which is a huge Dutch company that does building management software. So we would sit underneath that as a more active control for high-value crops. So there is some talks with them, as well as AutoGrow and some of the legacy people that are managing so much of the greenhouse, the irrigation, all of these other aspects where we can just be laser focused on that indoor environment and controlling the CO2 uptake of those plants.
Great. Okay.